To start it up, you click on launch. You're using the Jupyter notebook. You can use any of the text editors of your choice. However, as a beginner, I will strongly recommend that you learn to use notebook first. If you become more familiar with it, you can switch to another one that could be more of your own choice. It is more easy to use the Jupyter, and you can at each point in time see the output of a line of instruction that you wrote. Okay, so when you begin to have bugs, you can easily trace them to see where the bugs are coming from. It makes it much easier to use Jupyter Notebook than to use Spider, to use PyCharm, or even having to code them in Sublime, but running it on top of Python. Okay. So for now, let's use Jupyter Notebook. In some other classes, we can switch to PyCharm. So then those of you who want to learn to use some other text editors, you'll still be able to make adjustment. All right. So when you open it up, it will bring you to the home page. Okay. Now before you create any file in there, you will need to navigate to the location on your machine where your files or your data sets are kept. Okay, so then you will have your script to have direct access to your data set. Okay, so in my case I have, okay, so this should be the home page. I have kept mine in a folder. You would have a different directory, so more navigate to where you have the same data set file as we used in the previous class. Mine should be somewhere over. Okay, so I think I got it. This must be it. All right, so this is the file you want to use, the music CSV. So make sure you have navigated and you are in the same point. This is the file you want to use. All right, so if at this point, if any of you do have any challenge, you need to let me know. If you have any questions. Only I may say. Any questions, please? Okay, so in the absence of any questions, then we'll move on from there. So just navigate and be sure you are in the same location where your data set files are kept. Okay. Hey, my good friends, can you just use your valid view email address to join the class? Okay, so when you have done that, you click on the button new. That should be at the top right, just beside of the button upload. We have the button new, right? So you click on that, and then what we're using is Python 3. So this creates for us the notebook, right? We have already gone through this example. So what I'm going to do is to move a bit faster with this. What we said was that the first thing you must do is to import what? Is to import the data. How do you import the data? You import the data using a library called what? Pandas. Okay, so do not forget this. This is fundamental. It is going to run through even with complex projects that we may be looking at subsequently. All right, so you have to write your import statement, import pandas, and then you want to give it an alias. So then all the time we will not be typing pandas throughout. Okay, so we want to give it an alias. You use the keyword as, and then you call it PD. You can use any name, any other name of your choice, but in common practice, in common practice all the time, the alias for pandas is used as what? PD. Okay. So when we have done this, we have not imported the database, sorry, the data set yet. Let me put it on top so that I don't get anybody confused. All right. So importing the data. This doesn't import the data, but this imports a library. The line we have here imports a library called pandas that will help us to now what? Import the data. Okay. Let's take a quick glance at the data rounds again. Okay, so this is the data set we're looking at, music.csv. You would need to understand your data set in full. All right. So when you look at this in the data set, we have three fields here: age, gender, and then genre. All right. My good friends, hold on a few seconds. An upcoming call. This guy is disturbing. Let me just few seconds. All right, sorry. So looking at the data, the data is made up of three fields: age, gender, and then genre. And then this is a fake data, huh? So it is very easy to do with. At genre, you can tell that by speculation, all those within the age of 20 to 25, and then by gender are male, represented by 1. The online shop would want to recommend the hip hop genre of music to that particular new person that will come. So the concept in here is that we are trying to mimic an online shop where people will buy some online music or music. Okay, so when there is a new person that has come to use the application, what kind of a genre of music should be recommended to that individual? Okay, so that is what this data set actually contains. So by this, it is supposed to consider your age range and then your gender, and then based on that historic data of other people who use the application and then what they did like, the application should suggest to you some range of what music that falls within a particular genre. So in this case also, from the age 26 to 30, and then if it's a male, using one representing a male, we want to say that in the past, all of those within that age range and were male did like what? Jazz. Likewise, all male between the age 31 and 37 also did like what? Classical. So if there is a new user to the system, although the person has not yet interacted with the system, but having a clue of the new user's age, and then gender can suggest which of the genre of music that person may likely want to buy from. Okay, so in the case of also of female, looking at the range from 20 to 30. Okay, 0 representing gender female. By this historical data, it is suggesting that from the age range 20 to 25, for a female, they all did like dance music. Okay, so by this also, any new user that is having the age between 20 and 25, and then it's a female, you are expecting that the app will, based on this historical data of the old users of the system, to suggest that the person would want what? A dance genre of music. Okay, so basically the understanding of this data set is that given your age and then gender, it should be able to recommend to you a genre of music. Okay, that concept must be clearly understood. Okay, so then when you are you're moving on to selecting a model, it will give you a very good clue what exactly is the expectation in here. In this case also, number two, you must learn to understand that the input fields are age and then what? Gender. What we are learning to predict is what? Is the genre, given the age and then the gender. Okay. So with this understanding, we can go back to importing the data set. Okay, so in the first line we have here, what we have simply done is to import the library that will help us to now import the data into our data set. How do you import? We will need to define a pandas data frame. Okay, so a pandas data frame variable, we want to call that, let's say, music data. Okay, now we are going to use the alias of pandas. We call that pd dot read underscore csv. This is a function. Okay, this is a function. The function takes a parameter. It takes an argument which is the name of what? Of the data set. What's the name of our data set? This is it. Okay, so by doing this, we are using the function read underscore csv to load the content of the file music.csv into a data frame variable called what? Music underscore data. If you want to run that, you hold on shift and then you press on enter, or you can just press on, click on run over here at the top. Okay, and then that's it. So by this, we have not asked the environment to display anything, so it doesn't display anything. If you want to see what is actually inside of this variable, you can just rewrite the name here. I just did copy and paste, and then you still hold on shift, you press on enter. So over here, we can see the content of the data set showcasing itself at the side. So we still see age, gender, and then what? Gender. I hope at this level it works fine for everyone. It is just the same file as we used last week. If you have any issues, you will need to prompt me in the chat panel. Okay, so when you have loaded the data, what is the next step? Okay, look at this case. In this case, we don't have any of the cells being empty, isn't it? We also have the same total number of rows across board, all for 17 records. In some cases, you could have one of the fields being truncated from the other. So you could have 17 for, let's say, 17 records for the column age, but for gender that could be shortened by about 2. So maybe you have 15. Okay, in that case, you need to either fill in those missing values by using a median value, or you may want to delete those rows. Or if it is a column that is almost half empty, if you think it is not so much important, then you will need to consider deleting it. But in this case, because it's a very fundamental example, we already have the 4 dimension of data within our data set. It means we don't have to bother ourselves undertaking all of those tasks. Okay, so now the next thing we're doing is to split the data set into the input and output sets. How do you do that? Most of the time, the input set is denoted with the data frame variable X. In good practices, it's supposed to be an uppercase X. But for some of us, the lazy programmers, we would all the time use the one that quickly we would type. I would quickly type a small letter than using an uppercase. Okay, so I don't bother myself. I won't call myself typing an uppercase here. All right. So the name of the data set is what? Music underscore data. We want to pick the input fields. What are the input fields here? The input fields are age and what? Gender only. Is that correct? So we are looking at your age and then gender, and then we will learn from this existing data to suggest that because all those who were within of the age range 20 to 25 did like hip-hop, then you may also like what? Hip-hop. Okay. So what we want to do is that we want to drop this column, the column gender, because that is not one of the predictors. What are helping us as predictors is age and what? Gender. How do you do that? We use the function called what? Drop. Oops, not dropped. Maybe columns. Okay. What you want to drop is named what? Name what's general. Okay, so let's test run this if you have done the correct thing. All right, so we don't have any error. It means you have done the right thing. So what we simply done in here is to use the function called drop. How should it drop? It should drop a column called what? genre, okay, which is the output column. If you want to be sure if you did the right thing, we can just type in X here, hold on shift and then press on enter. So over here you can see that we have only what? Age and then gender. So we are sure that X contains only the input set. Okay, it contains only the input set. We would need to now move further. Let me see if you have any questions. We will need to move further to do that for the output. Now, to get the predictors, what we want to pick is from the data set called the data frame. What we want to pick is the column called what? Genre. Okay. Let's be sure that is exactly what we have. Good. So you can see over here we have only the values under the column what? Hip hop. These are just unique identifiers identifying at each row what value we have in here. So do not picture this numerical indentation here as also content of what? Of the column. But instead, these are the columns, the values in within of the column. Okay. So now what we have been able to do is that we have the X, which is we have been able to split the data set into the input and output set. So we have the X and then we have what? We have the Y values also. At this point, do you have any questions? At this point, do you have any questions? So if you said you didn't get what we did last week, that is why I'm going over. All right. All right, so moving on, now we have been able to split, so then we have both the X and then the Y values. What we would need to do now is to what? Build the model. How do you build the model? We build the model by literally introducing a variable or a placeholder that will hold the model that we want to select. Okay. So we simply selecting a learning algorithm. That is basically what at this level we are doing. Okay. So the learning algorithm that we want to use, we calling that decision tree classifier. A classifier with double S. Okay. So in this case, what we are simply doing is to create an instance of the subclass called what? Decision tree classifier, which will mean that we will need to import this into the application. How do we have access to the decision tree classifier? Understand this fundamental concept. There is a library which is serving as the superclass called sklearn. Sklearn contains several other libraries or classes for which we can extend to and then use in our program. Okay, so this is in the superclass called tree. In the superclass tree, we have the subclass decision tree classifier. There are different other kinds of tree type of a learning algorithm. A very common example is the random forest classifier. They are all used for classification. Okay, so we can what we can do is we can import. We can put it here or go to the very top and then put it there. It is the same thing. Just we need to be extremely careful that maybe there is not any line of code we have written here at the top earlier that would require that same library we are importing. Okay, otherwise you may have to double import. That will give us an error also. So my good friends, let me just help you do standardized programming. Okay, let me not teach you my lazy programming. So let's put it here at the top. It is a best practice to put it at the top, but you can put it anywhere and then it should still work fine. So from sklearn, which is the superclass that contains the subclass called tree. From this, we will want to import the class called what? Decision tree classifier. Okay, so this is the major library in itself. We are importing from this class, the subclass decision tree classifier. All right, so what we have done at the lower side in here is because we have imported this, the decision tree classifier. Let me run it. Okay, when you put it at the top, be sure you have run it, so then it will get to affect the subsequent lines of instructions that you have written. Just run it through it all. All right, so we have imported the decision tree classifier here at the top. What we must move further to do is to create an instance of that class in here. So by what we have written in the cell 13 simply means that anytime we want to call the decision tree classifier, we would instead call what? Model. We don't want to be typing all the time decision tree classifier, decision tree classifier. That is the model we want to use, so we are just calling it what? Model. I hope this is clearly understood by all of us. Okay, so at this point, what we can move on a step further to do is to make what? Make predictions. Let's run this. This Java and C++ will not kill man. In Python, we don't have any terminators in there. I am still in my Java mode. So you hold on shift and then press on enter. It should work fine for you. Right? So now what we need to move on further to do is to train the model. How do you train the model? You train the model by invoking the name of the model, which is the decision tree classifier. So in this case, if not because we did this, what we're going to have done was to write the name of the function, decision tree classifier dot whatever we want to now put. Okay, so we use the function fit. That will take the input x and then what? And then y. As we did here at the top. So we have the x from this side, and then we have the y from this side. That is what we are passing on to the function called fit, and that should do what? The training. Okay, this is where we got to, and then in your case, this the tree structure didn't show up. It is not an error. Okay, it is not an error. It is because there are some functions we have not yet used. You have not yet used in your application, so it has not gotten to the showcases of in your environment. It is not an error at all. Right? It should only be a worry if what you're going to write in the next line is showcasing an error, then it is a worry. In any case, there should definitely be an answer to it. All right. So on the cell 16, what we did was literally to train the model. Okay. What we want to move on a step further to do is to do the prediction. This is what we didn't do in class. Those of you who earlier on were saying that you had issues understanding. What is semicolon? No, there's not supposed to be a semicolon. Well, now I understand why I was getting errors. I was terminating my code. You are also in the Java mode, right? You will not need to terminate. If you are using an if you write the if construct, instead if constructs in if and then the for loops. In Python, you use a column, not a semicolon, to end the first conditional section. Okay. All right. So at this point, if you have any questions, you can leave them in the chat panel. I'll quickly give a response. Okay. So if you understand, then quickly move on. How do you make predictions? How do you make predictions? You make predictions by still using the model, and then we call a function called what? Predict, which there should be with a C. The function. It's a function called predict. But in our case, because we are using the decision tree classifier, the prediction model picks a two-dimensional array. Okay, so we need to pass on two dimensions of values to it. This should be one of it, and then there should be another. Okay, so what do you want to predict? We want that whatever we would predict would be stored into a variable. Let's call it a predict or prediction. Okay. So let's understand our data again. So this picks age and then what? Gender, right? Age and then gender. So let's assume that there is a male representing 1, but this time has the age 21. Okay, if it has the age 21, let's look at the full set. If the age is 20 and then the gender is 1, the genre that is recommended is what? Hip hop. How about if it is 21? That is what we don't know yet. So in this, let's suggest that the age is 21. The age is 21 and is a male, right? By observation from the data set, if the age is 21 and then it's a male, it should be hip hop, because the age from 23 to 25 from the age 20 to 25, they all do like the genre of music, which is what? Hip hop. So that is what is recommended. Okay, so in the same scenario, we are expecting that if we run this, it should give us a prediction that is suggesting what? Hip hop, because it's the age is 21 and then the gender is what? A male. Let's look at the situation in which it could be for a female. A female is represented with 0. Okay, so from this side, let's say if we use 26, if the age is 26 and then the gender is 0, then we want to recommend what? An acoustic genre of music. So we go down in here, and then in this array we pass on 26, and then what? 0. Oops, not 260. There should be a comma here, and then 0. Okay, so let's hold on shift and then we press on enter. We have an error. Ta-da. So let's look at why we have the error. Value error, expected 2D array, but got what? A 1D array. Okay, so let's resolve this. Where do we have it? So the brackets must be 2. I don't know if you can see. I have zoomed to the very maximum. The square bracket. Okay, so let me take this off so then you can get it very well. This is the first bracket. This must be the outer bracket. Okay, and then you must have 2 square brackets within it. It should be this way. Is this okay with all of you? So when we put it back, oops. When we put it back, it must look this way. So we have this as 1-dimensional array, and then there is another 1-dimensional array. When you put these together, we have a 2-dimensional array. If it worked fine for all of you, let me know. If it didn't, also let me know. Masa. Kabla then.
Say it worked.
It works.
Say it worked.
Okay, sir. Okay, so now we want to know what has been predicted. So whatever was predicted is passed on to the variable content, to the variable prediction. Okay, so we hold on shift and run it here. Here it is telling us hip hop and acoustic. Would that be correct? If you have the age 21 and then the person is a male, should it be hip hop? So we can tell from here if it is correct or not. 21 is within the age range of 20 to 25, and then they all do like what hip hop. And then we likewise also did pass on the ages 26, and then the gender is what 0, which is female. So let's check again from the data set. Where we have a female is denoted with 0. Age 26 is acoustic, so the prediction is correct. Let me know if it worked fine for all of you up to this point. If you have any questions also, please leave them in the chat panel. Any questions, please? All right, so at this point, we have done something extremely basic in machine learning. Okay, so if there is nothing at all you have learned, we have learned to know basically how to import data. You will need the library called what? Pandas. That is what we wrote over here. We need the library called pandas to help us to make access to the function called what? Read underscore CSV. And then in this case, we put the file in the same repository where we put our scripts in the same repository where our data set is what? Is available. Okay. So over here, this function loads the content of the data into this variable, and that makes the variable music underscore data a data frame what? Variable. Okay. We could have put this into the function print. It should still work fine. It's the same thing. But anytime you call the name of the variable to do the same. That is why we didn't bother putting the print function there. I hope you understand. So if you get to use another book and then they are using print to print the content of the data set, it is not wrong. It is the same concept. Okay, it wouldn't give you anything totally different from there. All right. So moving on, we also learn how to use the function drop to take away the output field. So then we'll have only the input fields. In this case, we had just 2 fields, and then we wanted to use both of them for the prediction. So we drop just the column general, okay, and then we pass that on to x. X is the standardized name of the variable that must hold the input fields, and y represent that which must hold the output fields. Okay, and then we learn how to select a model. It's just by calling the name of the model. But before you do this is to create an instance of the model, and then we pass that on to a variable called model. Before you write this, you should have imported that from sklearn. And then in sklearn, what we actually want to import is the decision what? Classifier, which is available in the superclass called what? Tree. Okay, so there are different kinds of tree classifiers, but the one we wanted to use was the decision tree classifier. So we imported that on. Okay, so over here we created an instance which is supposed to suggest that the instance is equated to the object called what? Model. So anytime we want to make reference to the function decision tree classifier, we instead use what? Model. And then to train the decision tree classifier or any learning algorithm, we use the function called what? Fit. So the function fit is inside of the class decision tree classifier. So what we're actually going to have written over here was to have done this. This is what we're going to have written. Okay. So for us not to be repeating this over and over and over again, that is why we put it equal to what? Model. Then we instead have model at the side. So model dot fit, passing on the input fields and then passing on the output field. We are asking the algorithm to pass on all the examples here to the decision tree classifier. So then when we give it new values like we have done over here at prediction, it is able to what? Predict. At this point, any questions? Any questions, please? All right, so let's move on. Now what we want to do is to evaluate the performance of the model we have created. How do we evaluate the performance of the model we have created? How do we evaluate? At this point, we will now have to split the data set into training and what? And then the testing set. Okay, at this moment, we want to keep our discussion simple, so we will not create the validation test in this example. Okay, but we instead learn to create or split the data set into the training and then the testing set. Okay, to do that, we will need to import a library that will help us do this. Okay, it is still available in the sklearn. Hold on. Before we import, let me start from a point that we can easily relate to. Okay. For me not to do a lot of navigations, my good friend, permit me to delete this. I want to have a small screen I can easily use it. And then I'll copy, or I'll just cut off this. I'll paste it in the same cell over here. It's the same thing we already did the last time. Okay, I'm doing nothing different. I just want to have more space in here so then you can easily see what I'm making reference to. All right, so what we're going to do at this point is to split the data set into training and testing. Okay, how do we do this? The splitting is going to be done into a tuple. The tuple will come as, use lowercase, so use a lowercase also, an S train followed by an S test. You have the space I have put here. No, it shouldn't be a thing. So you have Y train and then Y test. What are these things? What we're simply saying is that when we pick the data set and then we split it, the S string is going to represent what? The input what? The input fields. For the training, the S test is going to contain the other side of the testing data with the input section of it. Okay, and then the Y train and then the Y test represent also the the output section for the training, and then the testing data. Okay, so simply what we're doing is to split the data set into the training and then what testing set, which will come also in the X and then what the Y. The X representing the input, the Y representing the output. So in this case, we have both the training data set and then the testing data set. They are corresponding as columns. Okay, so what we're going to do is actually what is going to help create this split. This split is from the function labeled as train test split. What input does it take? It should have some argument. What we are going to pass it on to it is that you see in the earlier section, the full X, and then the full Y is the full data set, isn't it? But in this case, we want to split the data, so then a percentage of it would be for training, and a percentage of it will be for testing. So we will pass on X and then Y, and then we would add on that the test size. The test size is what 20%. We use 0.2. I hope it is visible at your end. Let me know. So the function train test split will pick all the input fields which is captured in the lowercase x, and all the output fields captured in Y, and then we are saying that the test size must be what 20%, which will mean that 80% automatically will be for what? Will be for the training. At this point, any questions? Okay, so we will need to include if you run this, you will definitely get an error because we have not yet created or imported the function that is for the train test split. Let me do lazy programming. I'll copy this. We go to the very top here. Okay, so what we want to include is from sklearn dot model what do we want to import? Import is the train test all right, so this is the function we actually want to use, the train test split. That is what is going to help us to split our data set into training and then testing, and then we are picking that from the class model selection. All right, so let's run this to be sure if it is working perfectly. Okay, so we didn't get any error, which means that is working. If you are getting an error, there could be a possibility that you also put your instructions here and then you didn't run it. Okay, if you did import the train test split at the very top cell, you must run all of your cells again. Okay, so hold on shift whilst you are within of the first cell. Hold on shift, press on enter until you have gotten to the latter. If you are getting an error, check on the spelling of the name of the model that we have using here. Be sure it is the same as you see on the screen, please. So Y0.2 test size. We can use any test size percentage, but in common practice, all the time the training test is 20%. Sorry. The test set is 20%. The training test must all the time constitute a greater percentage of the full volume of your data set. Okay, and most of the time it is 80%. In some few cases, it could be based on the kind of experiment you want to run. You want to use a different percentage value. Okay. Okay, so back again over here. What we have done is that we are using the function train test split to split the full length of the values in X and then Y. Okay, and then pass the first 80%. It will shuffle the first 80% and then pass them on to the S string or the input section into S string for training, and then the 20% section will be passed on to the variable S test. Also, the 80% training for the output column is kept in Y train, and then the 20% for the testing, which contains the output column in the test data, will be kept in Y test. You must understand this very well, and then also know the sequence. If you do S train Y test, you will begin to see some beautiful errors. You can, if you want to see errors, no problem. Let's just see some errors. If you put X and then Y, and then X and Y here. Let's run from the top. Okay, we are not seeing the error now because we have not passed on the true representation as it is supposed to be over here. Immediately we changed, we did the S split. It means that we didn't want to pass on instead to the prediction function raw values from here. Okay, but what we should be passing on at this point is supposed to be the testing values. Okay, the values for testing. That is what we must pass on to the side. Let me go line by line so then I don't get anybody confused. So this is supposed to be an X train SS, Y train Y test. This must be correct. Okay, let me save this and be sure. Okay, so look at this side. After, let me delete this. There's no need. I don't want to showcase this anymore. I want to take off this cell. Okay, great. So now what we have seen, what we have done here implies that if you run the model, instead of passing on the full length, as we did earlier on, we don't want to pass on the full length for the training. We want to instead pass on what? The training test only. the training data set only. In cell number 57, in my case, we have done the splitting here. This is for the training. The X is supposed to be a lowercase. You see, for whilst I'm trying to type in lower cases, they're helping me to pass on upper cases. Okay, so let me run this again. Okay, so at this side, we will need to change this to what? S train. And then we change this to Y train. Do you understand why we have to do this? Because we no more want to use the full data set to train the model. Do you understand? And we have done the splitting of the training and then the testing data set and then pass them to the X and then the Y train and then Y test variables. Okay, so where we want to train, we want to now be sure we are using only the training what? Data set. So at this point, we pass on the S train and the Y train. Is there any confusion? Let's be sure we have resolved that. Any questions on that? Okay, so if you have no questions, then let's move on. So at this point, let's run this. Okay, so we have no error. What we're going to do now is that at this side where we want to make predictions, what we would instead now pass on is what? What do we pass on over here? Over here, now we're going to pass on the S test. So the S test contains what? Contains the 20% columns of data, the input section. Okay, contains the input section. So that is what we want to use for the prediction. And then we want to see the output from this side. So you can see over here that we have classical dance. It's recommended classical dance, jazz, and then dance in there. Let's look at this. Let's just see what is stored inside of X. Okay, so S test, so then we can understand why it is making these predictions. Okay, so S test has 37 and then 1, 20, 21, 0, 30. Okay, so let's see if we can relate to the predictions. Why it is making these predictions, it is without the S. Okay, so let's see. 37 and then 1. It is supposed to be, if the age is 37 and then the gender is male, is it supposed to be classical? 37 and then male. Let's just be sure from the main data set. 37 and then male. Yes, that is correct. It is classical, so it is correct. And then 21, age 21, and then 0, which is female. 0, 21, dance. Did we get dance? That is correct. So as you see subsequently, they are all working correctly. So this is how you would want to do the splitting of the data set for evaluation. As it stands now, we have still not measured the performance of what? Of the algorithm. Now, to measure the performance of the learning algorithm, it is based on the prediction that was done in here. Okay, so we will create a variable. We want to call that score, and then we will say that it should make reference to an accuracy score function, and what we want to use that to measure is the Y test, and then the prediction. What is the original prediction value, and then what did the model predict in itself? Okay, so by that, this function called accuracy score will be able to what? Able to give us the value. Now, you understand that the accuracy score is a function, right? This function is actually available inside of the sklearn. So to use the accuracy score, to use this function, we must import it. My good friends, let's do lazy programming. In this case, this lazy programming will help you to understand it. Then I don't get to do a lot of navigation to the top and then back. You may not be able to follow. So from sklearn.matrix, it's a question for me. Is it normal for prediction to be different? Yes, it is normal that we would have different prediction because the function that was used for the splitting, based on the number of times you run it, it will keep changing its content. It has an internal section that is for passing on. Sorry, whoever was trying to join the class, I was late to click on. It has a line of code which suggests random shuffling of the records. Okay, so the 80% that you would get as training data, because of the function which is to randomize the records. In my case, it will be different. In the case of another person sitting close, you may be in the lab or somewhere else, it will also be different because of that function which is for randomizing the rules within of the data set. In our next two examples, we would look at the situation of the very technical detail within of the train test split. When you see the full algorithm and then code of it, you would appreciate why we would have different predictions, because the set of values that were used as training and then testing are randomized. So although we have the same data set, but we would have different predictions given at a point. It wouldn't be the same. I hope you got it right. Kwabena Safer. So let me simply put, yes, it is normal because of the randomization within of the train test split function. Welcome, sir. Okay, so invalid syntax. Apply from sklearn.matrix. What did I miss? Or I didn't complete it? Oh yes, it is true. From sklearn.matrix, what we want to import is the function we use, accuracy underscore score. Yes, this is exactly what we want to use. Predictions is not defined. Okay, so it should be without the S. That is correct, because if you can see from over here in the line number or cell number 70, we have prediction and then we don't have predictions. They're supposed to be without the X. So let's run this again. Okay, so what we need to do now is to showcase the content of this. Hey, overfitting 1.0. You understand why it is 1.0? Because we have just some few number of rows in the data set. That is why it is reading as what? 1.0. You got 0.5. Then in your case, the shuffling is the reason why you have 0.5. At this point, did it work fine for all of you? Any questions? Any questions? Okay, so let's play around with this and then see. We are going to change the text size from instead of 20%, we want to instead use 40%. 40% of the total data for testing. Okay, let's save this and then let's run it and then see if the accuracy will still be the same. And you see what happens when we reduced the training data. It has reduced the accuracy. That's reduced the accuracy by almost about 37%. Okay, so if you take it further to, let's say, 60%, so then you have more testing data than training. Also look at it again. Let's save first and then we run it. You see the accuracy reduces further. I hope by this we're able to appreciate. If you want to improve the accuracy reading, one of those parameters that you can be playing around will be the sizes of the testing and then the training data. Okay, so as you are increasing the number of examples, that is, whilst you are increasing the volume of data for training, automatically the performance of the learning algorithm would increase. In theory, it will mean that you are giving more examples to the learning algorithm if there is more training data. If you reduce the training data, it means you are giving it few examples, so it can't learn well. That is why measuring the accuracy of this learning algorithm, you would get 0.27 and some coins, because in this case the testing data is instead what, 60%, which will mean you are using only 40% to train the algorithm. There should be more training data than testing data. I don't know when you're you can show your screen and then I'll help you resolve the errors that you have. Please, I had 0.75. Yes, you will get 0.75 based on the value you have set for the test set, or it would also be because of the shuffling that is done. So you have different rows in the data set for your training set and then test set than I have. Okay, although we are using the same data set, but because of the randomization that is done in there, it is not the same records that are in your training data sets that I would also get in my situation. Each person will have a different records, and that will influence the reading of the accuracy.